Okay, so in this video, we're now going to solve one-step multiplication or division inequalities. Again, this is going to be exactly the same thing, pretty close, to how we solve one-step addition and multiplication equations. So again, use the inverse, balance the scale, do the math, check your answer. So looking at this one, I'm going to draw my balance scale. Okay, this is saying 3 times a number, and I want the answer to be greater than or equal to 12. So how do you undo multiplication? The inverse is division, balance the scale. This will cancel out. I'm left with x, drop my inequality sign, do the math. 12 divided by 3 is 4. So pick a number greater than or equal to 4. I'll pick 5. 3 times 5 is 15, which is greater than or equal to 12, so it checks. Looking at this one, this is division. We are taking x divided by 4, and we want an answer less than 5. So I undo division with multiplication, balance my scale. That will cancel out and leave me with x. Drop my inequality sign. 5 times 5 is 25. So as long as I pick a number less than 25 and plug it in, I will get an answer. Whoops, that's incorrect. 4 and 20. So as long as I pick a number less than 20 and divide it by 4, I'll get an answer less than 5. So I'll pick 16 because I want a number that's easily divisible by 4. 16 divided by 4 is 4, and 4 is less than 5. So I'm good to go. Now, so far everything with multiplication and division with inequalities is exactly the same as equations. There is a difference though in certain inequalities, and that is if this number that we are dividing both sides by or multiplying both sides by is negative, it will change things. And let me show you what I mean. If I give you two numbers, like the number 5 and the number 6, and I ask you which inequality sign fits in there correctly, you would say the less than, because 5 is less than 6. Now, if I draw a balance scale and decide I'm going to multiply both sides of this inequality by -2, which I can do because I'm balancing the scale. Am I solving an inequality or equation? No, but I can do this. 5 times -2 is -10. 6 times -2 is -12. Now, if I asked you to pick the correct sign, you would have to pick greater than, because -10 is greater than -12. So when you are multiplying both sides by a negative, that's going to lead to the sign actually flipping. We're going from less than to greater than. Both the numbers are positive. We made them both negative. That's going to change and flip the sign. Let me give you another example. I give you 9 and -6, and I ask you to put the correct inequality in. We would pick greater than because positives are greater than negatives. Now, if I draw a balance scale and to decide to divide both sides by a negative, this is now -3, and this is now +2. Positives are always greater than negatives, so again, the sign switches. Okay? So, yes, solving one-step multiplication and division inequalities are the same, except if you multiply or divide both sides by a negative, you have to flip the sign. Okay, so I did 2 examples at the beginning where I did not flip the sign. So we are not doing this all the time, only if we multiply or divide both sides by a negative. So right here, I'm going to solve this inequality. The inverse of multiplication is division. So I'm going to divide by -3 and balance my scale. This is what I need to look at. I am dividing both sides by a negative, so I'm going to have to flip the sign. So I'm going to do that right now. I already know that this sign is going to flip. That will cancel and give me x. 12 divided by -3 is -4. So I need to pick a number that is less than -4. If I pick -5, -3 times negative 5 is a positive 15, because a negative times a negative is positive. So it does end up being greater than 12, and it checks out. If I give you this. Now, a lot of people think, oh, I see a negative, so I'm going to flip the sign. You will not, because if we go through the process, we're going to divide both sides by a positive 5. Again, you're looking at this number. This number is a positive, so we do not flip the sign. It's going to stay the same. It doesn't matter if that's a negative. This is x is less than negative 2. And that would be our final answer. Let's do one more. Okay, so to solve this equation, make that negative 2, I need to multiply both sides by negative 3. Again, this is the number I look at. Because I'm multiplying both sides by a negative, I am going to flip the sign. That will cancel and give me x. This will now give me a positive 6. So if I pick a number less than or equal to positive 6, so I'll pick 3. 3 divided by negative 3 is negative 1, and negative 1 is greater than or equal to negative 2. So it is the same except at this step. If it's a negative, we flip the sign. If this number is positive, we're going to keep it the same.